Hello students, in this video we will be learning about solving various problems on triangles from exercise 7.1. We are on our third question. In the previous video we solved the first and the second question. In this question we are asked AD and BC are equal perpendiculars to a line segment AB. If you have a look at the diagram that we are given, it is said AD and BC are equal perpendiculars to a line segment AB. That means these two are equal in length. Okay, we are also said that this is a perpendicular, that is AB. That means we'll have perpendiculars over here. These will form 90 degrees angles. We are asked to prove CD bisects AB. Bisect means cuts it into two equal parts. That means we need to prove OA is equal to OB. And if we need to prove OA is equal to OB, we can do that if we can prove these two triangles to be congruent to each other. So via CPCT we can easily say OA is equal to OB, or in other words that CD bisects AB. And let us begin with our solution. We begin with what we have been given. So we start actually from the triangle that we need to prove congruent. So we'll say in triangle COB and triangle DOA, what do we have? We have been given CB is equal to DA. You can say that this is given. AD and BC are equal perpendiculars. We are also given that these two are right angles. So we can say angle CBO is equal to angle DAO, both equal to 90 degrees. This is also given. Now we've got side, we've got an angle. What else do we have? If we carefully have a look, these two angles form vertically opposite angles. So we can say angle COB is equal to angle DOA, and these are vertically opposite angles. So we've got a side, we've got an angle, we've got an angle. We can, so by AAS we can say that these two triangles are congruent to each other. So we mentioned this over here. Triangle COB is congruent to triangle DOA by AAS congruence criterion. Okay. Now that these two triangles are congruent, we can easily say that OB is equal to OA by corresponding parts of congruent triangles. And this implies that CD bisects AB. Hence the proof. In our next problem, we are given L and M are two parallel lines. These ones intersected by another pair of parallel lines PQ. So this is parallel and these two are also parallel. We are asked to prove triangle ABC is congruent to triangle CDA. So these two triangles need to be proved congruent. Now if we carefully look, there are these two parallel lines which are intersected by these two parallel lines. In between, this line is parallel to this and this line is also parallel to this, which means this forms a parallelogram. We can write over here solution that P is parallel to Q and L is parallel to M, which is given. This implies that AD, or rather we'll begin, since we said P is parallel to Q, we can say AB is parallel to DC and AD is parallel to BC. And because these two are parallel, we can say, therefore we can say, or rather we can conclude that quadrilateral ABCD is a parallelogram. What does a parallelogram property say? That the opposite sides of a parallelogram are always opposite to each other, but apart from being opposite to each other, they are also equal. So if we say that they are it is a parallelogram, we can also conclude that AD is equal to BC and AB is equal to DC. We can say 1 and 2. We've got this one equal to this, AD is equal to BC and AB is equal to DC. Now we'll go to the two triangles that we need to prove congruent. So in triangle ABC and triangle CDA, we can say AD is equal to BC and AB is equal to DC. You can say from 1 and 2. See, AD is part of triangle CDA and BC is part of triangle ABC. Similarly, we have AB, which is part of triangle ABC, and DC, which is part of triangle CDA. So we've got the sides equal. I'll mark those sides. AD is equal to BC and AB is equal to DC. And now if we have a look carefully, the side AC is shared by both of these triangles. So we can say AC is equal to AC, and that is common side. And now we can conclude that triangle ABC is congruent to triangle CDA. And how? By, see, all our sides 1, 2, 3. So by SSS congruence rule or criterion. So we have proved triangle ABC congruent to triangle CDA. If you have liked this video, please click the like button, share it with your friends and classmates. Please subscribe to the channel and click on the notification icon, that is the bell icon, to be notified whenever a new video is posted. Thanks for watching. See you in the next video.